Problem number 3 reads, in the Bohr theory of the hydrogen atom, the single electron orbits the proton in circular orbits. The radius of the first circular orbit is about 5.3 times 10 to the minus 11 meters. A. What is the magnitude of the force on the electron? And B. What is the speed of the electron in this orbit? Let's take a look at our Bohr atom. Here we see an electron circling the proton. The data that we are given is that the radius of the circular orbit is 5.3 times 10 to the minus 11 meters. The charge on the proton and on the electron has the same magnitude and has a value of 1.6 times 10 to the minus 19 coulombs. The problem is to find the force on the electron and to find the speed of the electron in its orbit. All right, try to solve that problem before watching its solution. I've added one more piece of information here that we will eventually need for the problem, and that is the mass of the electron. That's 9.1 times 10 to the minus 31 kilograms. The force that we're looking for on the electron is directed towards the positively charged proton. The magnitude of that force is simply given by Coulomb's law. So we can write that the magnitude of F is equal to K, which is 8.99 times 10 to the 9th Newton meters squared per Coulomb squared, multiplied by the product of the charges. The charge on each is 1.6 times 10 to the minus 19 coulombs. So we simply have to square that. Divide this by the distance between the centers, 5.3, multiplied by 10 to the minus 11 meters, that quantity squared. If you carry this out on your calculator, you can verify that the force that you get here is equal to 8.19 times 10 to the minus 8 newtons. So that's our answer to part A. In part B, we're asked for the speed of the electron in its orbit. The electron is in a circular orbit. The force that we just calculated is providing the centripetal force necessary to move the electron in that orbit. And if we write the equation for centripetal force, that it is equal to the mass of the object multiplied by the speed squared divided by the radius of the orbit, we can solve this for the speed squared. That's equal to F multiplied by R divided by M. Putting in values for these, we would have this F is the force we just found, 8.19, 10 to the minus 8 newtons, times the radius of the orbit, 5.3, times 10 to the minus 11 meters. Divide that by the mass of the electron, 9.1, times 10 to the minus 31 kilograms. And if you carry out that, you should find that this is 4.77 times 10 to the 12th meters squared per second squared. That's V squared. To find V, we simply take the square root of that, and the square root of that turns out to be, the three significant figures, 2.18 times 10 to the 6th meters per second. So that is the speed of the electron in its orbit. That's a very large speed. It's over 2 million meters per second. So that's the answer to part B. We have completely solved our problem. Let us move on then to problem number 4.